In the last investigation, you made a model describing what happened to the salt that dissolved in the water. We are going to come back to our models of dissolving later, but today we are going to do something a little different. Scientists develop models to help them think about their ideas. Over time, they use data collected from experiments to improve those models. So here's a box that we can consider a model. This has an A on it. This is what we will call Model A. Today, we are going to make a model about black boxes. This would be one of the black boxes that we are going to be talking about. I have a bunch of these black boxes, and it sounds like something's inside, but I don't know what, because the boxes cannot be opened. They can, but we are not going to open them for this experiment. So we're not going to open them, so let's think about what's inside. It sounds like something's inside, so we are going to investigate and observe these black boxes, okay? So, let's think. What do you think they may look like on the inside? So even though the boxes can technically be opened by the side, we are not going to open them. This activity is not about opening the boxes and looking inside. It's about thinking and problem solving to see what could the inside look like without opening them. So I'm going to shake each model to let you guys see. So once again, this is Model A of the black box. Listen closely. Okay, be thinking about it and imagine. You could even close your eyes and try to just listen and imagine what it may look like on the inside. This is box B. Okay. This is box C. Remember, we're not opening. I'm using my listening skills and my problem solving skills in my brain. So once again, listen. And this is our last box, box D. So listen closely.
It's true. Each box has a marble inside, but there might be something else in there too. Remember, your challenge is to figure out what the box would look like inside if you were able to open it. What we have created here is a scientific model. A model is an explanation of an object, event, or system that cannot be observed directly. People make models of things that are very big, like the solar system, things that are very small, like particles, and things that are possible to see into, like black boxes. Sometimes models are thinking tools for us. They help us think about difficult things. Models are often used to communicate information and ideas. Creating models is part of the modeling process, but interpreting those models is another. The creators of this model think that there's a square inside the box. The creators of this model think that there is a net-like fence down the middle. You were able to construct detailed and sophisticated models without seeing what is in the boxes. Because we can't see inside the boxes, we have to infer what they look like inside based on the evidence that we collect. This is similar to making models of dissolving. We can't see the particles in the solution. Scientists often work by themselves on difficult problems for a while and then write articles about what they observe and publish them in science magazines called scientific journals. Your model drawings are your published journal articles. When scientists read journal articles, they sometimes find that other scientists are interested in the same problem. They then call a conference where they can get together to talk and work on the problem. Working together is called
collaboration.
Your group should try to reach a consensus. A consensus means that everybody agrees. Not by vote, but through observation, discussion, argumentation, testing of ideas, and evidence development. By the way, I've told you that all the box A's are the same, and all the box B's are the same, and so forth. When I look at the models from other classes, I find that different investigators came up with different models to explain the same box. That's interesting. Here's an example of the kind of object that may or may not be in that black box. It might not be this shape, but I don't know where it's stuck. But this is the kind of material it's made out of.
And now they always say congratulations.
Congratulations! What do the black boxes look like inside? There are many things in this world, like our black boxes, that can't be opened for a close look. The center of the planet Earth, particles, the sun, and so forth. We construct models to explain what they look like and how they work, based on the evidence we were able to get. When we get new information, we change our models to include the new knowledge. Models always represent our best explanation of how things look or work, and models can always change. How might you get additional data to improve your models? You could use things like magnets, probing with a thin wire, or even x-rays or strong light.
So last time you made models of the black boxes by drawing what you thought the inside looked like. You and your team reached a consensus, remember an agreement, in your drawings. While drawings are helpful models, it is sometimes difficult to determine if the models will behave the same way as the black box. In order to test our ideas, we need to construct a physical model. You can analyze and evaluate the behavior of your physical model, and then revise your model once again. All right, y'all, so our focus question was, what is the process to develop a model of the black box? Look back in your notebooks and reflect on the process that we've used so far to create these models. There's a few steps that you did without even realizing it. The 4 steps that you guys did were to number 1, observe to gather information. Second thing you did was construct a model based on observations. And we did that by drawing our pictures earlier. The third thing you did was analyze how the model performs as an explanation. Now the word analyze means reveal or discover. So you had to really think about how your model was and what the sound was that you compared it to. And the last thing we did was revise the model based on new information or feedback. And revise is just another word for change. You might have said change in your groups, but what you really did was revise. Cut this out.
Are your published journal articles?
They're black boxes that can't be opened.
Did we say I wasn't gonna say that? Steps that we did, even if you didn't realize it, that we used to complete this idea. That don't make no sense. I did not.
I thought it was good.
I didn't like it. I feel like a grandma in this cardigan. Done.